In this question, it is given that let fx is equal to the set containing elements 1, 2, 3, 4, 5, 6, 7. Then the relation R is equal to the ordered pair xy belonging to A cross A such that x plus y is equal to 7 is. You have to find the correct choice. It's clear that A cross A is equal to 1, 1, 1, 2, 1, 3 up to 1, 7, 2, 1, 2, 2 up to 2, 7, 7, 1, 7, 2 up to, that is I can say in A cross A 49 ordered pairs are there. But according to given information in R, those ordered pairs will come in which x plus y is 7. That is sum of first element and second element of ordered pair is 1. Only those ordered pairs will come in R. For example, this first will be 1 6 and 6 1, 2 5 and 5 2, 3 4 and 4 3. That is in R, these 6 ordered pairs will come. It is clear that it is not reflexive because you know that 1 1 2 2 3 3 4 4 5 5 6 6 and 7 7. These ordered pairs must be present, then only the relation is called reflexive. It is clearly symmetric. From this set, it is clear that if AB is belonging to R, then BA is also belonging to R. It's clearly not a transitive relation because condition of transitive relation says that if AB belongs to R, BC belong to R, then AC should belong to R. It's clear that 1 6 is belonging to R, 6 1 is belonging to R, but 1 1 is not belonging to R. Therefore, I can say this relation is not transitive. Hence, I can say first choice is correct. Actually, when I had found that relation is symmetric, it means first choice is correct. Therefore, I need not proceed to find the relation to be transitive or equivalence. I have checked this just for completeness and making your concept more strong.